Hello everyone, welcome to today's class. Today in 10th standard science part 1 we are going to discuss chapter 2. Chapter name is periodic classification of elements. So in this chapter we are going to discuss how the elements are classified. So we know that elements are classified in the periodic table. So how the modern periodic table have been developed means before the periodic table that we see in this time there was other arrangement of elements. So we are going to discuss about all that in this chapter. So let's recall what is a matter. So matter is anything that has mass, volume and occupies space. Means anything that takes space and has mass is called a matter. And matter is divided into three categories: elements, compounds and mixture. So what is an element? Element is a pure substance which cannot be broken down by chemical means. So element is pure substance means it contain only one substance and it cannot be broken down by any chemical means, and element is made up of atoms. So the basic unit of the element is atoms. Next is compound. So what is a compound? NaCl. So here NaCl is an example of a compound which cannot be separated easily. So a compound contain a mix of combining of two elements is called a compound which cannot be separated easily. And a mixture. So a mixture is also a combination of two elements which can be easily separated. Next is atom. Atom is the smallest unit of ordinary matter. So a matter consists of atoms. Next is molecules. What are molecules? There are two types of molecules: molecules of element and molecules of compound. Molecules of element contain the molecule of same element only. A molecule of element contain the atoms of only same element, and a molecule of compound contain the atoms of two or more different elements. So the molecule of element means it has atoms of same element. Molecule of compound means it contain the atoms of different elements. Next we are going to discuss Dobie-Reiner's triad. So the Dobie-Reiner arranged elements into triads on the basis of the properties of elements are related to their atomic masses. So he suggested that the properties of elements are related to the atomic masses. He made a group of three elements each and having similar chemical properties and called them triads. So he made a triads, and a triad contain three elements which having similar chemical properties. So arranged three elements in a triad in an increasing order of atomic masses. So we seen that Dobie-Reiner arranged elements into triad, and in how he arranged elements in a triad. We know that a triad contains three elements having similar chemical properties, and he arranged elements in a triad in the increasing order of their atomic masses. And he showed that the atomic mass of the middle element means in a triad there are three elements. So the middle element was approximately, atomic mass of the middle element was approximately equal to the mean of the atomic masses of the other two elements. So here in an example of a triad is given, triad of lithium, sodium and potassium. So in this triad the middle element is Na. So he suggested that the Na or sodium. So the sodium's atomic mass will be the average. Mean means the average of the atomic mass of the other two elements. Other two elements are lithium and potassium. So the atomic mass of sodium will be the average of these two elements atomic mass. So to get the average we need to add the atomic mass of these two elements, that is 6.9 plus 39.1 by 2. So we will get the average of the atomic mass of these two elements, that is 23.0. So we will get the atomic mass of sodium as 23.0. So this is what he states, that the atomic mass of the middle element that is sodium, will be equal to the average of the atomic mass of the other two elements, that is lithium and potassium. All the known elements could not be classified into the Dobby-Reines triad. So this is a demerit of his Dobby-Reines triad, that the all elements cannot be classified in the form of a triad. Next we are going to discuss the Newland law of octave. So Newland's law of octave, he arranged the elements known at that time in an increasing order of their atomic masses. So Newland also arranged the elements in on the increasing order of atomic masses. It started with the lightest element, hydrogen, and ended up with thorium. So he started arranging elements in increasing order, means from lightest to the heaviest. So he started from, based on atomic mass, he started from hydrogen, it is the lightest, and ended up with the heaviest element, that is thorium. And he found that every eighth element had properties similar to those of the first. So in the Newland's law of octave, when he arranged elements in the based on atomic masses, every eighth element had similar property those of the first. So the properties of elements are repeating after every eighth element. The properties of elements are similar to those of the first. So the first and eighth element are showing similar property in Newland's law of octaves. The similarity observed in the eighth and first element as the law of octaves. So the similarity in the eighth and first element is called the law of octaves by Newland. So the similarity in the eighth and first element is known as the law of octaves. So we can see an example. So in this table you can see that sodium is the eighth element after lithium. You can see from the 1, 2, 3, 4, 5, 6, 7, 8. So sodium is the eighth element after lithium. So they have similar properties, and also magnesium has similar properties with the beryllium. Newland compared this similarity with the octaves in music. You can see sa, re, ga, ma, pa, dha, ni, and after ni it is coming to again sa. That means from first to the eighth element, the first and eighth element are same, means they are having the same chemical properties. Now we are going to the limitations in Newland's law of octaves. Law was found to be applicable only to up to calcium. So this similarity in first and eighth element was applicable only up to calcium, and properties of the new elements discovered later on did not fit into the Newland's law of octaves. So when new elements were discovered after that, so it didn't fit into this similarity of first and eighth element. New elements didn't fit into this arrangement or new law of octaves. Newland placed two elements each in some boxes to accommodate all the known elements in the table. So he placed two elements in same boxes to accommodate all the known elements, because he had to arrange all elements known at that time in the table. So he arranged two elements in the same table. Next we are going to discuss Mendeleev's periodic table. So so we have discussed Dobby-Reines triad, and also we have discussed the Newland's law of octave. So next we are going with Mendeleev's periodic table. So Mendeleev's periodic table is the most important step in classification of elements. Means it is a most important classification. Before the modern periodic table, Mendeleev's periodic table is very important. Mendeleev considered the fundamental property of elements, namely the atomic masses, as standard, and arranged 63 elements known at that time in the increasing order of their atomic masses. So he arranged elements on basis of what fundamental property? He arranged elements by considering the fundamental property of element as their atomic mass as a standard, and arranged 63 elements known at that time in the increasing order of their atomic masses. So he took atomic mass as the fundamental property or the standard fundamental property as atomic mass, arranged the elements in the increasing order based on the atomic masses. Then he transformed this into the periodic table of element in accordance with the physical and chemical properties of this element. So first he arranged the elements in increasing order of atomic masses, then he transformed the periodic table in basis of the physical and chemical properties of these elements. Mendeleev organized the periodic table on the basis of chemical and physical properties of elements. So on what basis he organized the periodic table? On the basis of chemical and physical properties. Mendeleev physical properties he arranged or organized the periodic table. Mendeleev found that the element with similar physical and chemical properties repeat after a definite interval. So like Newlands, Mendeleev also found that elements with a similar physical and chemical property repeat after a definite interval. On the basis of this finding, Mendeleev stated the following periodic law. So he stated periodic law. So we can see what he stated. So he stated the following periodic law. This is important. So this is his statement. Properties of elements are periodic function of their atomic masses. Periodic function means after a periodically it repeats. So we have seen that Mendeleev found that the elements with the physical and chemical properties similar means after a definite interval the physical and chemical properties of elements are repeating. So he stated the he stated the periodic law in which he says that the properties of elements are periodic function. Periodic function means the function which repeats at certain interval, periodically repeats on the basis of their atomic masses. So the properties of elements are periodic function of their atomic masses. And he also said the vertical columns in Mendeleev's periodic table are called groups. So the vertical columns are called groups. You can see group 1, group 2, group 3 likewise. And the horizontal rows are called periods. Period 1, period 2, period 3, period 4 you can see. So these are the periods and these are the groups in the Mendeleev's periodic table. Next we are going with the merits of Mendeleev's periodic table. So the atomic mass of some elements were revised so as to give them proper place in the periodic table in accordance with their properties. So later he corrected, revised means he changed the atomic masses of some element to give them proper place in the periodic table according to their property. And next is Mendeleev kept vacant places means free spaces in the periodic table for elements not discovered till then. So he knows that he predicted the discovery of some elements in the future, so he kept vacant spaces for them, means for that elements which will be found in the future. Mendeleev kept vacant places in his periodic table. 3 of these unknown elements were given the names Eka boron, Eka aluminium, Eka silicon, and from the known neighbors. So known neighbors means the neighbor of boron is Eka boron and neighbor of aluminium is Eka aluminium and neighbor of silicon means the vacant space were given near silicon, aluminium and boron. And this also he predicted the properties of that elements which will be found in the future. That is, this he already gave the name to those elements which will be found by scientists in the future, and he also predicted the properties of that elements. So this is a merit of Mendeleev's periodic table. Next is there was no place reserved for noble gases. Noble gases such as helium, neon and argon were discovered, so there was no reserved space for noble gases. So Mendeleev created the 0 groups without disturbing the original periodic table in which noble gases were fitted very well. So when noble gases were discovered, there was no space reserved for noble gases, but he created 0 group without disturbing the original periodic table. So here you can see that Mendeleev created vacant spaces for elements which will be discovered in the future. So gallium was discovered in the later period, but on Mendeley's time it was gallium was not found, but he predicted the discovery of gallium, and he named gallium as Eka aluminium. Since it the space was near the neighborhood of aluminium, he called it Eka aluminium, and he also predicted the properties. Which properties he predicted? He predicted that atomic mass of the gallium will be 68. You can see that it is nearly almost similar, it is 69.7, and also he predicted the density as 5.9. so you can see the actual density of gallium is only this much, 0.04 difference is only there, and also the melting point low 30.2 degrees Celsius, and you can see formula ECl3 Eka aluminium. So he called the named the formula of chloride as ECl3 gallium chloride, so ECl3, so GaCl3. Likewise he predicted the properties of the element gallium and other elements. So now we are going to discuss the demerits of Mendeley's periodic table. So the first is the whole number atomic mass of the elements cobalt and nickel is same. So in Mendeley's periodic table, whole number atomic mass means, whole number means when we approximately we take the atomic mass, so the atomic mass of cobalt and nickel were found to be same. So this is the demerit of Mendeley's periodic table. Isotopes were discovered long time after Mendeley. So when later isotopes were discovered after Mendeley's, isotopes have same chemical property but different atomic mass. A challenge was posed in placing them in Mendeley's periodic table. So the isotope has same chemical property but different atomic mass. So Mendeley's periodic table were arranged on the basis of the atomic mass, but in case of isotopes they have same chemical properties and a different atomic mass. So to give them proper place in the Mendeley's periodic table, there was a challenge. The next is, when elements were arranged in the increasing order of the atomic masses, the rise in atomic mass does not appear to be uniform. So means we cannot find a uniformity, means the non-uniformly the atomic masses are increasing when they are arranged on the basis of atomic masses, and it was not possible therefore to predict how many elements could be discovered between two heavy elements. So since they are non-uniformly the increasing order of atomic mass appear in the Mendeley's periodic table, so we cannot predict the discovery of how many elements will be discovered later between two heavy elements. Next is the position of hydrogen. Hydrogen shows similarity with halogens. Also hydrogen shows similarity in the molecular formulae of compounds of hydrogen alkali metal. So in Mendeley's periodic table there was no proper position for hydrogen. You can see that hydrogen shows similarity with the halogens, and also hydrogen showed similarity with the alkali metals. So considering the above properties of hydrogen, it cannot be decided whether the correct position of hydrogen is in the group of alkali metals or in the group of halogens, since hydrogen has similarity with the halogens and the alkali metals. So there is no proper position for hydrogen. So that is a demerit of Mendeley's periodic table. Next we are going to discuss with the modern periodic law. After the discovery of electron, scientists started exploring the relation between electron number of an atom and atomic number. So after discovering electron, before that what is inside the atom or the inside structure of atom was not known at that time. So after discovering the electron, the scientists started exploring the relation between the electron number of an atom and the atomic number. Electron number means the number of electrons inside an atom, and the atomic number in Mendeley's periodic table only indicated the serial number of the elements. So the atomic number showed in the Mendeley's periodic table was not the actual atomic number of elements. It was just a serial number of elements. The English scientist Henry Moseley experiments done using X-ray tube. So the Henry Moseley experiments done using X-ray tube experiment, that the atomic number of an element corresponds to the positive charge of the nucleus. So in the X-ray tube experiment found that the atomic number of an element is corresponding to their positive charge of the nucleus. Nucleus means the inner constituent of atom is nucleus. The number of proton in the nucleus. So the atomic number is either the correspond to the positive charge in the nucleus or the number of protons inside the nucleus. The inner unit of the atom is nucleus. So how many protons are there in the nucleus? Proton means positive charges in the nucleus. That is the atomic number of an element. This revealed that atomic number is a more fundamental property of an element than its atomic masses. So before the modern periodic time, atomic mass was given more importance than atomic number. So based on the atomic mass, the scientists like Newlands or Dobrenier or Mendeleev arranged their periodic table on the basis of atomic mass. But after the electron was found, atomic number was given the more importance, or atomic number was taken as a fundamental property, and the modern periodic law was stated as follows. So we have seen that Mendeleev stated the periodic law. So now here we are going to see the modern periodic law. The properties of elements are a periodic function of their atomic numbers. So the properties of elements means the properties of elements like atomic number, mass, density, everything is based upon the atomic number of that element. So before we have seen that Mendeleev's periodic law was properties of element are a periodic function of their atomic masses, but the modern periodic law is based on the atomic number. So here says that the properties of elements are based upon their atomic number. Periodic function means periodically after a certain period the properties of elements are repeating based on their atomic numbers. The next is modern periodic table. Long form of modern periodic table is also called long form of periodic table. So in the modern periodic table, elements are arranged in accordance with their atomic number. So before all the elements are arranged based on their atomic mass, but in modern periodic table elements are arranged in accordance with atomic number. Properties of elements can be predicted more accurately with the help of modern periodic table formed on the basis of atomic number. So now we can predict the properties of elements more accurately, means more correctly, with the help of modern periodic table because it is formed on the basis of atomic number. The modern periodic table is also called the long form of periodic table, and most of the drawbacks of Mendeleev's periodic table appear to be removed in the modern periodic table. And the ambiguity about the position of hydrogen, the hydrogen have the proper position in the Mendeleev's periodic table, it also removed in the modern periodic table since it is based only upon the atomic number.